Hello students, in today's class, let's learn how to find the inverse of a matrix by elementary row transformation or row operation. Okay, see I have taken two examples. First one is of 2 cross 2 matrix and second one is of 3 cross 3 matrix. Okay, find the inverse of 2, 1, 3, 4. And let A equal to 2, 1, 3, 4. Okay, I have taken this matrix as A. And we all know that A can be written as A into I, where I is the identity matrix of order 2 cross 2. See here, our matrix is of order 2 cross 2. So we need to take I of the order 2 cross 2. If it is of order 3 cross 3, then identity matrix will be of order 3 cross 3, 1 0 0 0 1 0 0 0 1. Okay, means if you multiply this A with this identity matrix 1 0 0 1, you are getting back this A. Okay, so we know that A is equal to A into I. So here in next step, I am taking this A in this place, and here I am writing this A as it is, and this I am writing this I here 1 0 0 1. Okay, and here what we'll do is we'll reduce this to identity matrix, that is we'll make this 1 0 0 1, and whatever the transformation you apply for this to make this as identity matrix, the same row transformation you will apply for this also. Okay, that is in each step. So to make this an identity matrix, first I need to make this one. Okay, so for that I will divide this row by 2. R1 is changing to R1 by 2. So 2 by 2 is 1 and 1 by 2 is half. And here also 1 by 2, 0 by 2 is 0. Okay. See, there is no transformation for row 2. So I will write this as it is. Okay. And now in the next step, I need to make this 0. Okay, and for that the corresponding row transformation that I'll be using is R2 changing to R2 minus 3R1. So using this row I'm making this 0. So it is 3 minus 3 into R1. So this will be 0 using this transformation. And here 4 minus 3 into half will be 5 by 2. And that is equal to A into, and there is no transformation for first row. I will write this as it is half 0, and for second row it is 0 minus 3 by 2, that is minus 3 by 2, and for this it is 1 minus 3 into 0, so it is simply 1. And in the next step I need to make this 1. Okay, and using this one I will make this 0. Okay, so that is how the concept works. So here I will make this one using the transformation R2 changing to 2 by 5 into R2. So if I multiply by 2 by 5 to this 5 by 2, this will become 1. So R2 is changing to 2 by 5 into R2. So 2 by 5 into 0 is 0. 2 by 5 into 5 by 2 is 1. And the same thing works here also. 2 by 5 into minus 3 by 2 is minus 3 by 5. And 2 by 5 into 1 is 2 by 5. And the last step here, I need to make this 0. Using this row, I will make the 0. And here you need to keep one thing in mind, that you need to use only row transformation and not column transformation. Okay, so I'll be using this row to make this 0. So here R1 is changing to R1 minus half R2. So using this transformation, this will become 0. And you need to observe one thing, this will remain unaltered. Okay, see, your transformation is R1 minus half R2. So it is 1 minus half into 0. Anyhow, you have made the 0, so that becomes unaltered. Okay, so you have 1 here, and here half minus half into R2, that is 0. Okay, and the same transformation you will use for this matrix also. So this transformation is for R1. So R1 minus half R2. So it is half minus half into minus 3 by 5, which is equal to 4 by 5, and 0 minus half into 2 by 5, that is equal to minus 1 by 5. Okay, and here there is no changes for the second row, as this transformation is only applicable for row 1 and there is no transformation for row 2. And here we have already reached the identity matrix on the left hand side, and here we will stop it. And this matrix is nothing but the inverse of matrix A. Why? Because see, when you multiply A to A inverse, then only you will get I. Okay, then only you will get identity matrix. So this matrix is nothing but the inverse of matrix A. So once you reach to identity matrix on the left hand side, here on the right hand side you will be there with inverse of a matrix. So we know this also, I is equal to A into A inverse. So this matrix on the right hand side is nothing but the inverse of A. So therefore A inverse is equal to 4 by 5 minus 1 by 5 minus 3 by 5, 2 by 5. So this is all about the inverse. How to find the inverse of a matrix using elementary row transformation. Okay. So now let's move on to the next example. And here we are having 3 cross 3 matrix. And let A be equal to this matrix. We know that A is equal to A into I. In place of A, I am writing this matrix, and in place of I am writing this identity matrix of order 3 cross 3. Okay, and I am retaining this A as it is. Okay, and now our goal is to reduce this matrix to identity matrix. That is, we need to make this 1 0 0 0 1 0 0 0 1, and we already have 1 0. So we will make this 0 using this row. Okay. So for that the transformation used is R3 changing to R3 minus 3R1. So you have 3 minus 3 into R1, that is 3 minus 3 is 0. Next you have minus 2 minus 3 into minus 2, that is 4. Okay, next 4 minus 3 into 2, that is minus 2. Okay, and similarly you need to apply the same row transformation here this side also. So you have for the third row, so first row and second row remains unaltered, and the third row according to this transformation will change. So it is 0 minus 3 into 1 is minus 3, 0 minus 0 is 0, and 1 minus 3 into 0 is 1. Okay, and next here you need to make this 1. Whenever you move to the next column, first you will make the thing 1, and then you will make these things 0 using this one. And here also when you move to the next column, you will make this one, and using this one you will make these two zeros. Okay, that you need to keep in mind. So first you need to make the thing 1, and then make these zeros using this row. And when you come here, you will make this one, and you will make these two 0 using this one. And similarly here you will make this one using this, you will make these two 0. Okay, so that is how it works. And now to make this one, I will divide the entire row by 2. Okay, so R2 is changing to R2 by 2. So it is 0 by 2 is 0, 2 by 2 is 1, minus 3 by 2 is minus 3 by 2. And here also 0 by 2 is 0, 1 by 2, 0 by 2 is 0. Okay, and next you will make this and this 0 using this 1. Okay. So for that, the transformation used is R1 changing to R1 plus 2R2 and R3 changing to R3 minus 4R2. And using this transformation, you have, see here for row 1, 1 plus 2 into R2, that is 1 plus 2 into 0, that is 1. Next, minus 2 plus 2 into 1, that is 0. Next, 2 plus 2 into minus 3 by 2, that is minus 1. Okay. And similarly, see R3. R3 is R3 minus 4R2. So it is 0 minus 4 into 0, is 0. Next, 4 minus 4 into 1, that is 0. Next, minus 2 minus 4 into minus 3 by 2, that is 4. Here also you need to use this transformation for row 1 and row 3 so that it becomes, see here, 1 plus 2 into 0 is 1, 0 plus 2 into half is 1, like 0 plus 2 into 0 is 0. And there is no transformation for row 2, and the third row we will use this transformation, and that is minus 3 minus 4 into 0 is minus 3, 0 minus 4 into half is minus 2, and 1 minus 4 into 0 is 1. Now we will make this 1, okay, and using this we will make these two 0, okay. And for that, the transformation used is row 3 changing to row 3 by 4. Why? Because I am making this one. So I will divide the entire row by 4 so that this becomes 1 and remaining things will be unaltered. Okay, because 0 by 4 is 0 and 0 by 4 is 0. And here minus 3 by 4, minus 2 by 4 is minus half, 1 by 4. Okay, and now I will make these two 0 using this row. Okay, so and for that the transformation used is R1 changing to R1 plus R3 because we have minus 1 and here we have plus 1. So minus 1 plus 1, and here we have minus 3 by 2 plus 3 by 2 into R3. So that is the transformation. Okay, so this will become 0 and remaining thing will be unaltered. Okay, and here on the right hand side, row 1 plus row 3 will be 1 minus 3 by 4, that is 1 by 4. Next it is 1 minus half, it is half. 0 plus 1 by 4, it is 1 by 4. And the second row is R2 plus 3 by 2 R3, that is 0 plus 3 by 2 into minus 3 by 4 is minus 9 by 8. Half plus 3 by 2 into minus 1 by 2, that is minus 1 by 4. Next, 0 plus 3 by 2 into 1 by 4, that is 3 by 8. And the last row will be as it is, as there is no transformation for R3. And here we have reached the identity matrix. So this matrix is nothing but A inverse. So here we have this, actually I is equal to A into A inverse. So therefore A inverse is equal to 1 by 4, 1 by 2, 1 by 4, minus 9 by 8, minus 1 by 4, 3 by 8, minus 3 by 4, minus 1 by 2, 1 by 4. So this is how you will find the inverse of a matrix, either 2 cross 2 or 3 cross 3 using elementary row operations. Okay, thank you.